Assalamu alaikum. This is Jihad Al Ghanim from Group 5. In this video, I will provide an introduction to CUDA and GPU in parallel programming. We will go through how modern graphics hardware is used to accelerate computational tasks beyond just rendering graphics. So, first of all, why do we use GPUs for computing? A standard CPU is designed with a few powerful cores optimized for serial processing. In comparison with the GPU consists of thousands of small or lightweight cores. So, this architecture itself makes the GPU ideal for data parallel workloads, where the same operation is applied to massive datasets simultaneously. Here, as you can see, we see the architectural differences. The CPU focuses on low latency and complex control logic, because it's the brain of the operation. The GPU, however, focuses on high throughput. It dedicates most of its transistor count to arithmetic logic unit, enabling the massive parallelism that the CPU simply cannot match for these specific tasks. And this brings us to CUDA. What is CUDA? Which stands for Compute Unified Device Architecture. Developed by NVIDIA, CUDA is a parallel computing platform and a programming model. It enables developers to use C and C++ to access the GPU for general purposes, effectively turning the video card into a supercomputer. And so the CUDA programming model is a heterogeneous. This means your host runs on the CPU, managing resources, while the device code runs on the GPU. The parallel code functions that execute on the GPU are called kernels. When a kernel is launched, it is executed by thousands of threads at once. And so to manage this massive parallelism, CUDA uses a hierarchy. The smallest unit is a thread, which executes the kernel. Threads are grouped into blocks, which can share memory. Finally, these blocks are organized into a grid. This hierarchy allows the code to scale across different GPU hardware automatically. So, understanding memory is critical for performance. Global memory is large and accessible by all threads, but has a high latency. It is slow. Unlike shared memory, is a much smaller but incredibly fast, and is shared only by thread within the same block. Using the right memory type is key to efficient programming. So, to summarize, CUDA unlocks the power of massive parallelism found in NVIDIA GPUs. It provides significant acceleration for data parallel workloads. However, realizing this speed requires careful design regarding memory hierarchy and thread management. And that's it. Hope this clarifies everything. Thank you for watching.